So today we're going to take a brief look at writing equations of parallel lines. We're not going to take a deep dive into it, but the reality is that if you can write equations of lines, you can write equations of parallel lines. Okay, the first thing that we need to know is these are parallel lines, right? When we're looking at this graph over here, these are parallel lines. Okay, parallel lines are lines that never intersect. It's not that they don't intersect on the graph, they never intersect ever. So if we were to continue those lines for forever, they will never cross. Okay, and if we look at these, right, and I start calculating the slope, this one has a slope of up 2 over 3, all right, and this one has a slope of up 2 over 3, right? They have the same slope, which makes sense, right? If their slopes are not the same, then they'll eventually get closer or further apart. So parallel lines are lines in the same plane that never intersect, and they always have the same slope. So I can always tell if lines are parallel simply by looking at their slopes. So for example, if I look at these two lines, right, this first equation is already in slope-intercept form, so it's easy for me to identify the slope. That has a slope of -1/3 because that's sitting in my M position. Now, this second line is not in slope-intercept form, it's in standard form. And remember, standard form gives us an x-intercept and a y-intercept. So I cannot find the slope unless I solve it for y and put it in a form that gives me slope. All right, so if I'm gonna solve this for y, I'm gonna subtract the 2x. And then I'm gonna divide by the 6. And so the equation of this line is y equals -1/3 x plus 2. And so now in the slope position is -1/3. And when I look at both of these equations, they have the same slope. So I would say, yes, these lines are in fact parallel. They have the same slope, so they must be parallel. All right, so I can do the same thing on this second one. Again, this one is not in the correct form to find a slope. So I would need to solve for y. If I reduce 6 over 8, that gives me 3/4. Okay, and so this one has a slope of 3/4, and this one has a slope of 1/4. Those are not the same slopes, so I would say no, these are not parallel. Now, we can also use this information about lines having the same slope to write the equation of a line. It's the same idea that we have been using. We need a slope and we need a point. Okay, so if I'm asked to write the equation of a line that is parallel to y equals 3/5 x minus 4, right? If I want it to be parallel, I know I'm going to use the same slope. Lines that are parallel have the same slope. So I'm going to find the slope from this line. Okay, I'm going to find the slope of that line and then keep the slope the same. So I want to use a slope of 3/5. I also know I want it to pass through the point 5, 1. So I know when I have a slope and I have a point, I'm going to plug this into point slope form. So I'm going to say y minus my y coordinate equals 3/5 times x minus my x coordinate. Right, and like we said yesterday, we never want to leave equations of lines in point slope form. So we want to distribute, which will give us a 3/5 x minus 3. I'll undo subtracting 1 by adding 1. And so my parallel line will be y equals 3/5 x minus 2. Now, oftentimes students will say to me, well, what about this -4 up here? But this -4 is part of this line. It's y-intercept. I don't care what its y-intercept is because I only want to know the slope. Parallel lines only share the same slope. They don't share anything in common about their y-intercept. So that number isn't relevant to me writing the equation of a line that's parallel. Okay, so let's say I want to write the equation of a line that is parallel to this and that passes through this point. So I'm going to find my slope. My slope is 3. And I want to keep the slope the same because parallel lines have the same slope. Right? And then I'm going to plug into point slope form. So I'm going to say y minus -6 equals m times x minus my x coordinate, which is 2. Right? I need to solve this for y. So these two negatives make a positive. 3x minus 6, I'm going to distribute. Then I'll undo adding 6 by subtracting 6. Be really careful. This is a -6 minus 6. So I'll get y equals 3x minus 12. Now, if I look at this next one, this can be a little bit frustrating because I'm not given the slope, which means I have to find the slope. And to find that slope, I am going to have to solve this for y, right? So I'm going to move my x over. Now be careful, that's a -3y. And then I'm going to divide by -3. And students often think, oh my gosh, that's already a lot of work. I must be done, but you're not. All that did was give me my slope. So that tells me I want my slope to be -7/3, and I need it to pass through the point -9, -7. So I'm going to say y minus -7 equals -7/3 times x minus -9. Right, two negatives make a positive. I'm going to start distributing. So -7/3 x, minus 21. Again, use a calculator to help yourself if you need to. I'll say -7, so I'll get y equals -7/3 x minus 28. Now, I don't always have to be given the equation in function form, right? I could also be given the equation on a graph. So if I want the equation of the line that is parallel to this, that passes through this point, I just have to find the important information. So I need the slope, right? So slope means find two good points. So it looks like I'm going up 1 over 2. So I have a slope of 1/2. And I need it to pass through this point. So I need it to pass through the point -2, 2. Now you have two options here. You absolutely can plug this into point slope form, and I'm going to do that in just a second. But you can also say, well, this still needs to have a slope of up 1 over 2. And you can see that this has a y-intercept of 3. And so you could instantly go to y equals 1/2 x plus 3. But watch what happens if I plug this into point slope form. Y minus 2 equals 1/2 times x minus my x coordinate, which is -2. So those two negatives make a positive. So I have 1/2 x plus 1 when I distribute. Right? And I end up with the exact same equation that I saw if I went the other way. So while you might not notice that right away, you would still get to the exact same answer and be correct. Okay, so if we look at our next one, here we need to have a slope. Let's see if I can find a couple good points. So I'm going up 1, 2, 3, and over 2. Now I counted left right here, so that's a negative slope. So if I count here, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, right? I could do that same idea. So I'd have that y equals -3/2 x plus 5. Or I could name this point. It's the point 4, -1. So y minus -1 equals -3/2. 1, 2, 3, 4. I'm making sure I'm naming that point correctly. There we go. Okay, times x minus 4. Okay, so now I'm going to start solving. These two negatives make a positive. So this will give me a -3/2 x. A negative times a negative will give me a positive. So plus 6. Use a calculator if you need help with that. And I'll subtract the 1. And there's my y equals -3/2 x plus 5.